Okay, so yes, let's look at the syllabus here. Today is Thursday, and we will be doing some stats and method stuff. We started it last time. We'll finish it today. I have an in-class little discussion activity I have planned for us. We'll do some stats and methods problems, or scenario problems, I call them. And then you'll go into breakout rooms for those. Then you'll come back and we'll kind of go over the answers and a couple more things after that. And then we'll call it a day after that. So that's the plan for today. I'll point out your quiz questions, your Blackboard quiz questions over chapter 1 are going to be due Monday night at 11 p.m. Remember what I said last time. If something is listed on the syllabus for Tuesday, then your questions over that reading will be due the night before at 11 p.m. I will have the questions for chapter 2. I'm going to try and have those posted by the end of the day today. And in general, I'll try and allow you to have 5 to 7 days before something's due to complete it. And so I'll try and have the chapter 2 questions on Blackboard up for today. Any questions or comments about things in general before we get started? Okay. So here is, I believe, where we left off last time. Maybe we should review. So the difference between subjects factor and within subjects factor. In a between subjects factor, a participant is in one condition only, whereas in a within subject factor, each participant is in all of the conditions of a given factor. And so I mentioned here on these hypothetical scenarios, this is a between subjects factor here. Amount of coffee is a between subjects factor here. Amount of coffee would be a within subjects factor in this scenario right here. So let's just make sure that we're still understanding this. Why is it correct to say in hypothetical scenario 2 that this is a within subjects factor? What do you see here in this scenario that is consistent with the idea that this is a within subjects factor? Can someone tell me that?
You can see that all the participants go through both forms of conditions.
Exactly. Yep. Participant 1 is in the no coffee condition. And that score right there, 5, is like some made up memory test. So if he drinks no coffee, then he gets a 5 on the memory test. Participant 1 then comes into the laboratory another day, drinks a cup of coffee, and then takes the memory test and then scores an 8 on the memory test. So that's within subject because each participant is exposed to both conditions, no coffee and coffee. Whereas in between subjects factor, each participant is in only one condition. Participant 1 is in the no coffee, participant 7 is in the coffee, etc. So this stuff is important because we have all these hypothesis tests that we can use to compare the means of the various conditions in a study. And you use different hypothesis tests depending on whether the factors in your study are between subjects or within subjects. So let's just go through some of this terminology to make sure that some of it's sunk in from last time. If I say factorial, what did I mention last time? Factorial, what does factorial mean? Anyone remember? We did talk about, I'm pretty sure we talked about this stuff last time, factorial.
2 or more factors.
Exactly. Thank you. Factorial means you have a study where there's at least 2 factors, 2 or more factors. And then one-way design would be what? What does one-way mean? Anyone?
One factor.
Good. Thank you very much. So those are 2 terms we went over last time. One-way means there's one factor in your study. Factorial means that there's 2 or more factors. Repeated measures means within subjects. Between subjects means between subjects. What does mixed mean? Anyone remember what mixed means?
Doesn't it mean both between and within subjects?
Yep, it means you have at least 2 factors, and one of them is between and one of them is within subjects design. There's a mixed ANOVA, which can deal with that situation when you have at least one between subjects and 1 within subjects factor. Let's see. Yeah, I guess we can probably get going. I'm trying to think if there's anything else to ask you. Oh yeah, and in what situation do actually no, yeah, I'll go on. And I'll ask that question later. Okay, so this is just some little helpful hints for choosing a hypothesis test given a research scenario. And I'm not going to go over these now, but you can use these. So I'm about to assign you to do some group work. I'll give you about 20 minutes. And you might want to use this to helping you answer some of these questions. This is just kind of, or when you're studying for test 1, I'm going to give you some research scenario problems, and you want to choose the hypothesis test that would be used to analyze the means in those research scenario problems. And here are some rules that will help you make those decisions. We'll do one together just to get us thinking in terms of these types of things now. So let's get going. So these are the questions that we'll be answering about each research scenario. There's 4 questions, A, B, C, and D. The first question is, what is the factor or factors in the study in each research scenario? And what are the levels of each factor? For each factor, indicate whether it's between or within subjects. What is the dependent variable? That's part C. And then finally, what is the hypothesis test that you would use to analyze the means for that given research scenario? And your choice of hypothesis test are right here. These are the same, I think there's 8 here. These are the same 8 that I showed you on the previous slide. So you're going to have to, in these research scenario problems, you'll have to do things like, how many factors are there? And are those factors between subjects or are they within subjects? And those are the types of things that you'll need to know in order to determine which of these is the correct hypothesis test to analyze the means. So let's start with this first one right here. I'll read it to you and then we'll talk about it and we'll answer these questions together. And then I'll break you guys off into breakout rooms and you'll do questions 2 through 6 by yourselves. So Dr. Rollo wanted, so these names were made up by an undergraduate student several years ago. That's why they're kind of silly. Dr. Rollo wanted to investigate how the sweetness of food affects how people feel, how full people feel rather. Participants ate 350 calories of sweet food or 350 calories of less sweet food. Participants were asked on a scale of 1 to 7 how full they felt, where 1 means not full at all and 7 means completely full. Participants were randomly assigned to one of these 2 conditions, sweet or less sweet. So the first thing, what is the factor in this study? There is just one factor. What is the factor and what 2 levels compose that factor? Anyone know what is the factor in this study? What is another word for it in this case would be independent variable. What is the factor in this situation?
Would it be sweetness?
Yes, that is correct. Sweetness. And then can you tell me what the 2 different levels would be?
Sweet versus less sweet food.
Excellent. Yes. So if it were me, I would call it like amount of sweetness. But if you just call it sweetness, that's fine too. But amount of sweetness, and then the different levels would be sweet and less sweet. People are randomly assigned to one of those 2 conditions. The factor is amount of sweetness. Is that factor between subjects or within subjects?
Between.
Thank you. It is a between subjects factor. Can you tell me how you knew that?
They were assigned to 1 of 2. They weren't assigned to both of them.
Good. Participants were randomly assigned to 1 of 2 conditions. It says it right there. Therefore, we know it's a between subjects factor. The dependent variable, I'll just give you, that is amount of fullness. So you have this 1 through 7 scale. Each participant indicates how full they feel on that scale. That is the dependent variable, the dependent measure. Okay, and then the last question, part D, what hypothesis test would you use to compare the means? There'd be 2 means that we're comparing. We would be comparing the mean fullness of people that ate the sweet food, comparing to the mean fullness of people that ate the less sweet food. What would be the hypothesis test that we would use to compare those means and why? And I'll give you a clue. There are actually 2 correct answers. 2 out of the 8 hypothesis tests that were listed would be the correct answer here. Anyone know one of those? Let's start with one. What is one hypothesis test that you could use to analyze these means?
Could you use a one-way between subjects ANOVA?
Yes, you could use a one-way between subjects ANOVA. There's one factor. And so when there's one factor, you can always use an ANOVA. It's one factor which is between subjects, so you could always use the ANOVA. But because there are only 2 levels, there's also another hypothesis test that we could use. What would be the other hypothesis test that we could use?
Is it the independent?
Yes, please continue.
It's the independent samples t-test.
Yeah, independent samples or independent measures or between subjects t-test. There's different names for it, but yes, independent samples or independent measures t-test, or in my head, I usually just call it the between subjects t-test.
I have a question.
Yeah, please.
Would it be incorrect to say that the factor is food and the levels are sweetness? Or
No, that would not be incorrect. That's fine. There's a lot of, really what I'm looking for when you're naming a factor is that long as you use some generalization as the name. So calling it type of food, and then there's 2 different types of food, the sweet type of food and the less type of food, that's perfectly fine. Or you could say amount of sweetness, and you could say sweet versus less sweet. So there's multiple right answers for these almost always. There's almost always several things that you can call the factor. What I really look for, the name of the factor is a general term, which is composed of the 2 different levels. And you did that, so that's fine. Any other questions or comments here? Okay. So there's 2, 3, 4, 5, 6. So I want you guys to do 2 through 6 in groups. Okay. I forgot to say this on the recording before I turned it off. For those people working non-synchronously, if you do decide to work in groups, you would be turning in a Microsoft Word document with everybody's name at the top. So each group will turn in one document to Blackboard with all of the people's names on it in that group. If you're working by yourself, you'll just have one name at the top. And the place to turn it in will be in-class discussion activities, which is this folder right here on Blackboard. And you'll turn it in right here. Today's August 27th. Any questions about that? You guys can still hear me, by the way, right?
Yeah.
Good. Are there any questions about this? Okay. So yeah, we'll go over the answers now. Another thing that I've wanted to mention, I will be doing a little bit of, we'll be going over these, and then we'll be talking about some things after that. And I just want to point out that although there's still only one slide, PowerPoint document on Blackboard, I updated it since last time. And so you might want to download, and this is kind of common, even if we're using the same PowerPoint slides for 2 consecutive days, it's very common that before the second day, I'll update the slides and make them newer. So what I would suggest for you is always download the most recent slides. If that's something, if you like to follow along the slides, which I do highly suggest, I would suggest just downloading the slides before each class because they'll always be the most recent ones. Okay, so let's go over these answers. Okay, we did that one. So here in this one, I'd be running. What is the factor in this study, in this research scenario? Anyone know?
Number of high fives.
Good, number of high fives. There's 3 levels, 0, 1, and 2 high fives. Let's see the next question. Oh, is it between or within subjects?
Within.
It is within subjects. Can you tell me how you knew that?
It says all participants completed each condition.
Yep, all participants completed each condition on different days. Good. And The dependent variable would just be the amount of time to run the race. Yeah, like the dash time, the 100-meter dash time would be the dependent variable. And then what hypothesis test would be used to analyze the means?
A one-way repeated measures ANOVA.
Exactly. Repeated measures, because we have a within subjects factor. It has to be an ANOVA, not a t-test, because there are 3 conditions. You can only do a t-test when there are 2 conditions. I'll remind you, you could also use an ANOVA when there's only 2 conditions. But when there are 3 conditions, only ANOVA will suffice. T-test will not work. So excellent. A one-way repeated measures ANOVA is exactly the answer. Questions or comments about this one?
What's the difference between factorial, repeated measures, ANOVA, and one-way?
Great question. One way means there is one factor. Factorial means there are 2 factors or more. So in this particular situation, there's only one factor, amount of high fives. Therefore, the answer is one-way ANOVA. We'll show some examples in a second where there's 2 or more factors, in which case the correct answer will be factorial ANOVA. One way means one factor. Factorial means 2 or more factors. Any other questions or comments? All right, moving on. Okay, so what is the factor in this one? This one always tricks me up. There are actually 2 factors in this one. I imagine it tricks some of you guys too. Usually there's 1 or 2 groups that do get both of the factors. So can anyone help me get the first one of the factors?
Gender.
Yeah, I usually will call it biological sex because I like to differentiate between biological sex and gender. So yes, biological sex would be one of the factors with 2 levels, man and woman. So biological sex, man and woman would be one factor. What is the other factor?
The extent of verbal motivation.
Ooh, I like that. Yeah, the amount of motivation or the extent of motivation, whose different conditions would be motivation and no motivation, motivation or no motivation. Very good. So amount of motivation or extent of motivation is one factor. And the other factor is biological sex. So we have 2 factors, which, by the way, that means this is going to be a factorial. Well, the answer will have factorial. The hypothesis test will have factorial in the name. But let's first, before we get to that, let's decide whether each of these is between or within subjects. So let's start with the kind of more tricky one. Biological sex, is that a between subjects factor or within subjects factor?
Between.
It is between. And the reason is because you cannot be in both conditions at the same time. Or I guess there are some rare examples in which you kind of can be in both conditions at the same time. But for the most part, you are categorized as either a man or a woman. And so biological sex is typically by definition, basically a between subjects variable because you can't be in both conditions. So it has to be you're in one condition or the other. And then the other factor, we call it extent or amount of motivation. Would that be between or within subjects? And justify your answer, please.
That one is between because they were randomly assigned to one of 2 conditions.
Excellent. Very good. And so we have 2 between subjects factors, though the dependent variable is test performance, score on the test. So what hypothesis test would be used here to analyze the means?
Factorial ANOVA.
Yeah, factorial between subjects ANOVA because both of the factors are between subjects. But yes, factorial ANOVA is correct. Though because I asked you specifically in these questions whether it's between or within subjects, don't forget the between subjects part. It is factorial between subjects ANOVA. But good, excellent. A couple more of these, 3 more of these, I think. Okay. Yeah, okay, so what is the factor here? Looks like there's only one. What is the factor here?
Amount of caffeine.
Yep, amount of caffeine, whose different levels would be decaf or no caffeine versus regular or some caffeine. So you can call it amount of caffeine or you could call it type of coffee. Either one would be fine. One level is decaf, the other level is regular. Is that factor between or within subjects?
Between.
Can you justify your answer? It's actually, I guess I should say, it is not between, so it's within, but I need someone to justify the answer for how it is within.
Oh, because they're counterbalanced, so it's kind of like randomized in a way.
Yeah, the counterbalancing, though, it does say
Yeah, okay.
do not consider counterbalancing a factor, so you can kind of ignore the fact that it's counterbalanced. So it is within, but I would like the explanation for why it is a within subjects factor. Counterbalancing is kind of relevant, but there's a more direct statement.
Each participant was assigned to all the experimental conditions.
Thank you. Each participant was assigned to all experimental conditions. Therefore, we know that type of coffee, amounts of caffeine, was composed of 2 levels, decaf and regular. We know that as a within subject factor. The dependent variable is reaction time on some spatial task, but really the dependent variable, you just call it reaction time. That's descriptive enough. What hypothesis test would we use? And I'll point out there are 2 correct answers here. There's 2 hypothesis tests that we could use to analyze these means. What is one of them?
One of them is the ANOVA one-way repeated measures.
Exactly. A one-way repeated measures ANOVA. Because repeated measures basically is a synonym for within subjects. One way means we have one factor. And so if you have one factor that's repeated measures, you can use an ANOVA. No question. That always works. In this situation, though, we only have 2 levels. So there's also another hypothesis test that we could use. What is the other hypothesis test that we can use?
Repeated measures t-test?
Exactly. A repeated measures t-test. T-test can... The regular t-test can be used when you have 2 levels, one factor with 2 levels. And in this case, because it's a within subjects factor, we would be using the repeated measures t-test. Repeated measures basically means synonymous with within subjects. Questions or comments on this one? Yeah, I guess we have 2 more left.
What was the dependent variable for that one? Just checking. Was it
yeah,
reaction time or?
Yes, reaction time is the dependent variable. Good.
Okay.
Okay, moving on here. Okay, yep. So what is the factor here?
The color of test-taking room.
Yes, exactly. And there are 3 levels: white, fluorescent green, and black are those 3 levels. Is that factor between or within subjects?
Between.
It is between because it says participants were randomly assigned to one of the 3 conditions. The dependent variable, test performance, test score. And then what is the correct hypothesis test here?
One way between ANOVA.
Yep, one way between subjects. ANOVA is the correct answer. You cannot do a t-test because we have 3 conditions. Once you have 3 or more conditions, you know you're supposed to be doing an ANOVA. So one way between subjects ANOVA to compare the means of those 3 conditions, and that factor is between subjects because participants were randomly assigned to one of those 3 conditions. And then finally, I saved the hardest one for last, or at least I think this is kind of the hardest one because there are 3 factors here. And you might not have got all 3 factors, but I imagine as a class, we will be able to get all 3 of these factors. So can anyone help me name one of the factors?
The type of drug.
Yeah, type of drug is one of the factors, which the 2 types of drugs are experimental and placebo. So that's one factor is type of drug. What's another factor here?
Noise level.
Yep, noise level, which is like noise versus no noise, or you could say loud background talking versus no background talking. So yeah, noise level is good, or amount of noise, which would be some noise versus no noise. So that's 2 factors. And then what's the third one?
Would it be the age-matched controls and ADHD?
Those are the 2 levels. Usually, so those are definitely the 2 levels, so you're definitely on the right track. When I ask the name of a factor, though, I always want like some general term, which is like the name of the factor. And so I usually would call this one like type of diagnosis or something. And then one level would be ADHD and the other one would be no ADHD. Or you could call it ADHD and the other level would be age-matched controls, like you said. Basically, what you said are the two levels. I would just want some general term to name the factor, which I call it type of diagnosis.
How was it clear in this question that you have children with ADHD and children without? Because this almost sounds like you only have children with ADHD.
This sentence right here, the researcher was interested in whether the drug differentially influenced the performance of children with ADHD and age-matched controls.
Okay.
Age-matched controls, yeah, the wording here, ADHD, and then age-matched controls implies that there are some individuals that do not have ADHD.
Okay, thanks.
No problem. So we went over the three factors. Now we need to go over each one is between or within subjects. So let's start with type of drug. The two levels are experimental drug versus placebo. Is this factor between or within subjects, and how do you know?
It's between.
It is between. Can one of you two people explain how you knew that?
They were randomly assigned to each one.
Yep, randomly assigned to either take the experimental drug or the placebo. So type of drug is between subjects. How about noise? I'll do this one. All participants were tested in both test noise conditions on different days. All participants were tested in both test noise conditions on different days. Therefore, amount of noise would be within subjects because they were tested in both conditions on different days. And then the last one is diagnosis. Would this be between or within subjects?
Between, right?
It is between. Once again, these participant characteristics like biological sex or type of diagnosis, whether you have ADHD or not, or whether you have an anxiety disorder or not. Those are basically by definition a between subjects factor because you can't both have ADHD and not have ADHD in the same day or at the same time. So it's basically by definition a between subjects factor. So we have one within subjects factor and two between subjects factors. By the way, the dependent variable is test performance once again, or test score. So we have three factors. One is within subjects, two are between subjects. So what type of hypothesis test would be used to compare the means of these three factors?
Factorial mixed ANOVA.
Yep, factorial, which once again means two or more factors. Here we have three. And mixed is the correct answer because we have at least one within subjects factor and at least one within subjects factor. So that's it for these scenario problems. I wanted to give some examples here of some of these designs, and I'm going to give you some examples from actual research. And then I'm also going to give some made up examples, some graphs that I just made myself to illustrate some points about the means that are compared in these different research designs. So here is a study, and I talk about this in more detail in one of my other classes called the Mozart effect. You might have heard it before. This was the original study published in the journal Nature 25 years ago or so. And in this study, people were, it was a within subjects factor. So participants completed all three conditions. And if you look at this figure there, you can see all three of the conditions. Music, relaxation, and silence are the three conditions of this study. What happened in the music condition is people listened to a Mozart piece for about 10 minutes. It's a Mozart with two pianos song. So they listened to Mozart music for about 10 minutes. In the relaxation condition, participants listened to like a relaxation tape. So they listened to someone who was speaking about, trying to get like one of those relaxation meditation type of things. That's what the relaxation condition was. And then in the silence condition, you just sat by yourself for 10 minutes, not doing anything. So we have these three conditions: listening to Mozart, listening to a relaxation tape, or sitting in silence doing nothing. In each case, you're doing something for 10 minutes, but there were different things that you were doing. And then what they had the participants do was a spatial IQ test. So IQ tests usually have like a spatial component and a verbal component. In this particular study, they were just interested in the spatial component of the IQ test. So you were in one of these three conditions. You did one of those things for 10 minutes. Then you took this spatial IQ test. And what I wanted to see is, does your performance on the spatial IQ test, is it influenced by the thing that you did for 10 minutes, whether you're listening to Mozart, whether you're listening to a relaxation tape, or whether you were just sitting in silence for 10 minutes. And you can see the dependent variable, or you can see the figure right here, the graph of these three conditions. The height of the bars represents how well they did on the spatial task, the spatial IQ task. Looking at this, it's pretty clear that if you're in the Mozart condition, the music condition, your performance on the spatial IQ test was better than if you were in the relaxation condition or the silence condition. Now, if you look, I say this is an example of one-way ANOVA, and if you look right over here, it says a one factor, and they call this the factor listening condition. They could have just called it type of exposure, or type of 10-minute task, music, relaxation, or silence. Repeated measures, analysis of variance. So the fact that it's repeated measures, meaning this is a within subject factor, that means that on day one, a person came in and they listened to music. On day two, they came in, that same person did relaxation. And on day three, that participant came in again and they just sat in silence for 10 minutes. And each day they took that spatial IQ test. And the ANOVA, which compares all these means, found that there was a significant difference. Let's see. And they said, basically, I'm not going to find the exact thing, but the music condition had it was significantly higher than the other two conditions. So the question I have for you, it said that they did a one factor or a one-way repeated measures analysis of variance. Why is this the correct answer? Why is one way repeated measures ANOVA? Why is this the correct answer here?
Because the only factor is the listening part, and then there's 3 levels of that.
Exactly. There's one factor with 3 levels. So when you have one factor, you always know you'll be able to do an ANOVA. So, and the fact that there's 3 levels means that we cannot do a repeated measures t-test. Repeated measures t-test would not work. Why would a repeated measures t-test not work here?
Because there's more than 2 levels to the factor.
Exactly. We have 3 levels here, and so we can't use a t-test. So we use an ANOVA instead. One way, repeated measures, ANOVA. So this is an example of a one-way ANOVA from an actual study, a highly cited study in a very good journal, Nature. So that was a one-way design because there was only one factor. And to be honest, that it's actually pretty hard to find published studies where there are only one factor. They're especially in journals like Nature. Usually the studies in Nature and Journal have many, many factors, and the statistical analyses are so complicated that they're actually hard to understand. One of the things which is great about that study I just showed you is because it's so simple and so straightforward of analysis. One factor with 3 levels. It's rare, and it's actually, as a teacher, it's actually hard to find a lot of examples of studies that use one-way designs because they're rare. What's much more common in psychology, and especially in neuroscience, which is what we're doing in this course, obviously, is factorial designs, where you have 2 or more factors. Especially in a cognitive neuroscience class, factorial designs are basically the norm, because cognitive neuroscience, by its name, implies that we're interested in the cognitive component and the neuroscience component. And often, though there are kind of some exceptions, usually one factor is going to be manipulating some cognitive component, and then there's another factor which is going to be manipulating the neuroscience component. And so in cognitive neuroscience, factorial designs are basically the norm. Almost everything that we're going to be dealing with in this class is going to be factorial designs. And they can handle the research designs that are most common in neuroscience. The issue with factorial designs is that they're just a little bit more complicated. They're a little bit more difficult to understand. And so we're going to go through some examples of factorial design, some made up examples that I made up just for the purpose of simplicity and teaching. And then at the end of this chapter, which I don't actually think we're going to get to today, I'll do it in the next class, I'll show you an example of a factorial design from cognitive neuroscience. So I'm using these behavioral examples so far just because they're the simplest. And then towards the end of this, once I think you're starting to get the hang of it, then I'll show you an example of a factorial design from cognitive neuroscience. So first off, I want to talk about this little nomenclature right here, 3 by 2. In any factorial design, you can always apply this factorial nomenclature. So what this means is that this would be an example of a 3 by, so that x is 3 by 2 factorial ANOVA. So the amount of numbers here represents the amount of factors that we have. So you see that there's 2 numbers right here. We also have 2 factors. There's factor 1 and there's factor 2. That is why we have 2 numbers here. And you see that this first number is 3. The reason this is the number 3 is because if you look at the first factor, amount of coffee, you see that it has 3 levels, 0, 1, and 2. That's why the number 3 is here. If you look at the second factor right here, which is number 2, it corresponds to type of diagnosis, which is composed of 2 levels. A person that has, people that have schizophrenia compared to people that do not have schizophrenia. So 3 by 2 factorial number, ANOVA has 2 factors. One has 3 levels, the other factor has 2 levels. So this is factorial nomenclature. Here is another example, a 3 by 2 by 2 ANOVA. This has 3 factors, and you can see that because there's factor number 1, there's factor number 2, and there's factor number 3 right there. Factor number 1 has 3 levels, 0, 1, and 2 cups. Factor number 2 has 2 levels, schizophrenia and no schizophrenia. And factor number 3 also has 2 levels, biological sex, whether you're a man or whether you're a woman. So these are just 2 different, these are made up examples. You know, this is the type of study that could definitely exist. Yeah, here's just the rules that I was just saying. The amount of numbers represents the amount of factors, and the value of each of those numbers is the amount of levels that compose that factor. So I'll talk about these terms. I don't know if we're going to get through the examples today. Maybe we can get to one example. These are the terms that I think students really struggle with. And I know here in the statistics course at KU, you don't actually differentiate between these 2 terms in stats. However, you should be differentiating between these 2 terms if you've taken research methods. And these are terms that you will really only find when you're dealing, once again, with factorial ANOVA. And I'll remind you, factorial means, well, I want someone out there to remind me. Can someone remind me, what does factorial mean?
2 or more factors.
Thank you. 2 or more factors. When you have 2 or more factors, there's lots of means to be compared, and we can compare those means in different ways. And those different ways of comparing the means are categorized by these 2 terms here, main effect and interaction. And so I kind of admit that these terms they're difficult to define in a way that helps students really understand what these terms mean. Really the best, I have the definitions here and you can read them. Like for instance, for the main effect, if it's significant, it indicates there's a difference among means, among conditioned means for one of the factors. But really the way to understand what these 2 terms mean is just to be exposed to lots of examples and then to understand the examples. But a main effect is basically, if we have a factorial design, we have multiple factors. But when you're dealing with the main effect, you're looking at the various conditions of only one of the factors, and you're basically completely ignoring the other factor. That's what a main effect is. I'm paying attention to one factor, and I'm completely ignoring the other factors. That's what a main effect is. And so if you have a 2-way design, if you have a 2-way factorial design, that means you have 2 factors. You're going to have a main effect for factor A, where you're just looking at that factor and you're looking at the various conditions of that factor. Are those conditions, do they differ for each other? But you'll also have a main effect for factor B. I'm comparing the conditions among this factor. And each time you're doing a main effect, you're looking at just one factor and you're ignoring the other factor. You look at just this factor and you're ignoring the other one. So that's like the characteristic of main effects. You're looking at the conditions, you're looking at the mean differences among the conditions for one factor while ignoring the other. It's still a very wordy definition, even as I say it. And so I'll show you some examples, which I think will help connect the verbal definitions that I'm giving you to a more concrete example. I think that will really help us sink this in. Interaction is the term that really gives people fits. And I remember as an undergraduate, this term differentiating between main effects and interaction was definitely a challenge for me as an undergraduate. And I don't think it really was 100% solidified until like probably my second year of graduate school. But I want you guys to understand it as best as you can. So an interaction is different than a main effect. And when you're dealing with an interaction, you're comparing the means of all of the conditions simultaneously. And then here is probably the main thing to know about the verbal definition of interaction. If it's significant, then it indicates that there's a difference among conditioned means for one factor, which is influenced by the levels of the other factor. So this is the definition that like, this is true, but like every time I say the definition of interaction, it's always like, you know, it's very complicated and it's true, but really I don't think anyone understands the definition of interaction just from reading this definition. It's like, oh yeah, I get it. Really the only way to understand what an interaction is to see this definition and to connect it to some concrete examples. The difference among conditioned means for one factor is influenced by the levels of the other factor. That's true, but let's see some examples now. Yeah, so here would be an example of an interaction right here. And the reason we have an interaction is because if we look at, these are made up data. By the way, what would the factors here be? We have two factors, and we know that because it says a two-way interaction. What are the factors that we have here? Can we name them?
The diagnosis.
Diagnosis, which is levels or schizophrenia versus no schizophrenia. What's the second factor?
Coffee.
Coffee. Amount of coffee, 0, 1, or 2 cups. So this is a 3x2 design. And then I just made up some dependent variable. I call it short-term memory score. And when we have an interaction here, and you can see the interaction because if you, one way one way that people are taught to do interactions is to kind of draw a line. So for the schizophrenia, you would draw a flat line, but for the no schizophrenia, you would draw an increasing. Oh, I'll do it with my mouse. So for schizophrenia, you would draw a line like this, and for no schizophrenia, you would draw a line like this, which is going up, like a positively sloped line. And then one way that's often taught is if you find that those two lines intersect, that indicates that you probably have an interaction. That's an okay way. That's the way a lot of research methods will teach this. If the two lines, this line which is flat and this line which goes up, if they intersect, and they would intersect here, then you have an interaction. That's not the way I read graphs though. I look at the pattern in what I call the two columns. So the first column is this one right here, the schizophrenia column. And then I characterize kind of the pattern of the condition means here. And I call this a flat line pattern. So flat line pattern for one column, the schizophrenia column. Then the other column is the no schizophrenia column. And then the question I ask myself is, do the means in the no schizophrenia column, do they show the same pattern as they did in the schizophrenia column? And the answer is no, because in the no schizophrenia column, the pattern, I would, instead of calling it a flat line pattern, I would call it an increasing pattern. So we have these two different patterns, the increasing pattern and the flat line pattern. And because they're different, we would say, yeah, we appear to have an interaction here.
Is the terms you just used, the flat line and then the increasing, are those terms that we're going to need to know?
No. What you will need to know is I will be giving you, for instance, on test 1, I'll give you a picture of a graph, a couple graphs, and you'll have to indicate things like, does this graph show an interaction? Yes or no? Or does this graph show a main effect? So you're not going to have to, I don't think you'll ever have to justify using these terms that I'm using, like flat line versus an increasing. I'm just giving you different strategies for how to see the interaction. I don't really care what strategy you use. I just care on the final result. Yeah, so that's it. Good question. Any other questions or comments about this? So we need to wrap it. I do want to do one more thing here, which I just showed you what an example of an interaction, and we'll have time to go over that a little bit at the beginning of next class. But I also want to These are the same exact means right here. You see 4, 4, 4, 5, 7, 9. So here's the flat line pattern, 4, 4, 4. And then here's the increasing pattern, 5, 7, 9. This is literally the exact same means. I'm showing you here in a table, whereas here I showed you in a graph, 4, 4, 4, 5, 7, 9, 4, 4, 4, 5, 7, 9. And the reason I'm doing this is because, once again, you can see the interaction here. There's the flat line pattern. Here's the increasing pattern. The fact that we have an increasing pattern over here and a flat line pattern over here, these patterns are different, indicates that we probably have a significant two-way interaction. But I want you to be able to differentiate between an interaction and a main effect. And so right here, I've calculated the means which are compared for the main effect. Remember when I said when we're calculating a main effect, we're comparing the means of one factor while completely ignoring the other factor. So if we're interested in the main effect of cups of coffee, then we care about the means for the 3 cups of coffee condition, but we don't care at all about whether those individuals have schizophrenia or not. So we ignore the diagnosis factor when we're looking at the main effect of cups of coffee. And all we're doing is comparing the mean scores of people who drank 0 cups compared to 1 cup to 2 cups. And we basically combine the schizophrenia and schizophrenia people into the same, but don't differentiate between people depending on whether they have schizophrenia or not. We just care about, do they drink 0 cups, 1 cup, or 2 cups of coffee, and that's it. This number right here, 4.5, this corresponds to the 0 cups of condition. And the way I got that is that you see all these people in the schizophrenia condition. These are the people that drank 0 cups of coffee. And these people over here in the no schizophrenia column, they also drank 0 cups of coffee. And so if you add up all 20 of these scores and then divide by 20, you would get 4.5. So this is the average score of people that drank 0 cups of coffee, independent of whether they have schizophrenia or not. So in this mean right here, half the people have schizophrenia, half the people don't. We don't care about the distinction. These are just the people, their average short-term memory score of people that drank 0 cups of coffee. Another way of doing that, by the way, 4 plus 5 divided by 2 also equals 4.5. So this number 5.5, we get that if you add up all of these scores in the 1 cup condition and all of these scores in the 1 cup condition. There's 20 scores there. Add all 20 of those scores together, divide by 20, take the average. You get 5.5. Another way of doing that is 4 plus 7 equals 11. 11 divided by 2 equals 5.5. This is the average score of people that drink 1 cup of coffee. We don't care whether those people had schizophrenia or no schizophrenia. So we just pretend that that factor doesn't exist temporarily when we're looking at the main effect of cups of coffee. And then finally, for 6.5, this is the mean score of people that drank 2 cups of coffee. All of these scores plus all of these scores divided by the total amount of those scores, which is 20, I believe, gives you a mean of 6.5. Also, 4 plus 9 equals 13 divided by 2 equals 6.5 as well. So a question I have for you are these right here. So for the main effect of diagnosis, we're going to have to do something different. We have these 2 numbers that are compared from the main effect of diagnosis. The 2 numbers that are compared are the mean score of people that have schizophrenia compared to the mean score of people that have no schizophrenia. When we're dealing with the main effect of diagnosis, we don't care how many cups of coffee you drank. We completely ignore that factor the amount of coffee. And all we care about is, what is the mean short-term memory of people that have schizophrenia? What is the mean short-term memory of people that don't have schizophrenia? And we're going to compare those 2 things. So can someone tell me, how would we calculate the mean score of someone who has schizophrenia using these data right here? Can someone tell me?
So you add all the 0 cups, 1 cups, and 2 cups, and then you divide by 3, which is the total number.
Yes. Could you be specific? Which 3 numbers are you at?
So you'd add 4 and 4 and 4, and you'd get 12 divided by 3.
Exactly. So that would give you, So you could, there's actually 2 ways to do this, and your way is definitely correct. You can add up these 3 means: the mean of the 0 cups, schizophrenia, the mean of the 1 cups, and the mean of the 2 cups. You add those 3 scores together, which gives you 12, and then divide by 3. That gives you the mean score of people with schizophrenia, which would be 4. Does anyone know the other way that you could derive this mean of 4? Anyone know? For the sake of time, I'll just answer this one. You add up all, I believe there's 30 scores here. Add up all 30 of these numbers, divide by 30, you're going to get 4 as well. So what is this number then? This is the no schizophrenia group right here. This is the mean of people without schizophrenia. What is this number right here? This number was 4. What should this number right here be?
Should be 7.
7 is correct. Can you explain how you got that?
Yeah, I added the means of all 3 columns with 5, 7, 9. So you get 21 divided by 3, you get 7.
Yep, 5 plus 7 is 12. 12 plus 9 is 21. There's 3 means. 21 divided by 3 equals 7. The other way of doing that, which will give you the exact same number, is add up all 30 of the scores of people that don't have schizophrenia, and then you divide by 30, and that will also give you 7 as well. And so for the main effective diagnosis, the two numbers that would be compared is the mean of 4 for people, the mean short-term memory score with people with schizophrenia, to the mean short-term memory score of people without schizophrenia, which was 7. Those are the two numbers that were compared. So we'll review this stuff at the beginning of class next time. Then we will be moving on to actual chapter, like neuroscience stuff very quickly once we get to class. I guess it'll be Tuesday of next week. Please be looking out for Blackboard Quiz 2, which I'm going to try and have posted today. I believe I'll be able to get that done today. So Blackboard Quiz 2 will be posted today. Let me know if there are any questions or comments otherwise, so you guys can take off. See you later.
Bye, thank you.
Mm-hmm.
Thank you. Have a good one.
You too.